Intro to three-dimensional or 3D solids. Here are some three-dimensional solids. In this unit, we will learn about the unique features and discover formulas that produce the surface area and volume for each of those pictured and more. What's a dimension? Here are some one-dimensional figures. A ray, a line, and a segment are one-dimensional figures. You can measure with a ruler between points along a line. There is no width. Two dimensions. We have a triangle, a rectangle, and a hexagon. A triangle, a rectangle, and all polygons are two-dimensional figures. Each can be measured by finding lengths and widths in perpendicular directions. And here are some three-dimensional figures. A rectangular prism, a pyramid, and a cylinder are three-dimensional figures. Each can be measured by finding lengths, widths, and heights. Three-dimensional figures fill space in three directions. A one-dimensional segment has length. A two-dimensional rectangle has length and width. A three-dimensional cube has length, width, and height. To give a figure more of a three-dimensional look, lines that are not visible from the angle the figure is being viewed from are drawn as dashed or dotted line segments. These are called hidden lines. Alright, so we're over here looking at the figure like this, and so we can see the top, this side, and this side, but we can't see that side, this side, that side. So we draw these lines so that it looks more 3D, but it represents the fact that in real life we would not be able to see those lines. A polyhedron, or plural polyhedra, is a solid that is bounded by polygons called faces. An edge is the line segment formed by the intersection of two faces. A vertex is a point where three or more edges meet. So this is a face, here is an edge, and there is a vertex. Here are some prisms, some cylinders, and some pyramids. Here are some cones and spheres. All of the three-dimensional solids we will study have surface areas and volumes. These are the features that we will study. There are right prisms and oblique prisms. Here is an example of two prisms with pentagonal bases and heights as indicated. One is a right prism and the other is an oblique prism. Which is the right prism? Which is the oblique prism? What are the definitions of each? A right pentagonal prism is a prism in which the bases are congruent pentagons that are parallel, and one is directly over the other. All of its lateral faces are rectangles. So here is a pentagonal base that is directly over a congruent pentagonal base, and the faces are rectangles. So here is a face. All right, over here we have an oblique pentagonal prism, which is a prism in which the bases are congruent pentagons that are parallel, but one is not directly over the other. All of its lateral faces are parallelograms. So here we have a pentagonal base that is over, but not directly over, another congruent pentagonal base. Because it's not directly over, the faces are parallelograms instead of rectangles. There are right cylinders and oblique cylinders. Here is an example of two cylinders with congruent circular bases and congruent heights. One is a right cylinder and the other is an oblique cylinder. The centers of the bases of a right cylinder are vertically positioned. This is not true of the oblique cylinder. So here the center is directly over the center of the bottom base, but here the center of the top base is not directly over the center of the bottom base. There are right circular cones and oblique circular cones. Here's an example of two cones with congruent circular bases and congruent heights. One is right and the other is oblique. Note the apex of the right circular cone is vertically above the center of the base. Here, it's directly above the center of the base. This is not true of the oblique circular cone, where the apex is over here. not directly above. Prisms have congruent polygonal bases that lie on parallel planes. The sides of each base are called base edges. The sides connecting corresponding base vertices are called lateral edges. In the figure, there are 6 vertices: A, B, C, X, Y, and Z, 2 bases, triangle ABC and triangle XYZ, 6 base edges, which are AB, BC, AC, XY, YZ, and XZ, and 3 lateral edges, AX, BY, and CZ, for a total of 9 edges. The polygons that make up the surface of the figure are called faces. The bases are a type of face and are parallel and congruent to each other. The lateral edges are the sides of the lateral faces. In this figure, there are 2 bases, triangle ABC and triangle XYZ, with the following properties. Triangle ABC is congruent to triangle XYZ, and triangle ABC is parallel to triangle XYZ. There are 3 rectangular lateral faces, AXBY, which is AXBY, so it's the one on the back side here. We have BYCZ, BYCZ, which is this face here. And we have CZAX, CZAX, which is this face there. This prism has a total of 5 faces.